test statistic. This is the case 2, case 1 and case 2 very similar as I mentioned. Only difference is case 1 we know what is the standard deviation. It is for that case we can use C-test. Case 2 we don't know standard deviation, but we can assume that our sample is approximately normal distributed, so we can replace sigma by S, which means sample standard deviation. Okay, that's the difference between case 1 and case 2. So we did this example right here. Just plug the values into that equation, and finally you have to decide whether we reject or do not reject. Rejection, I mean that decision whether you reject or not, it's same from chapter 8 to 9 as well. Okay, in this case 2 sample C-test same as the 1 sample cases, we can find confidence interval. Theory it remains same. So only difference is, see, in this case you have 2 sample means here, x bar and y bar, plus or minus C alpha over 2. I told you always alpha over, you have to use alpha over 2 once you find the confidence interval. Okay, square root of this sigma over sample sizes. Okay, this part. How we get sorry, how we get this using this previous equation. Okay, so did cross multiplication and we derive this. Okay, I showed you last time, I mean in chapter 7, yeah, chapter 7, how we derive this one. So exactly same, only difference is these two. Okay, consider it as just a one term. Okay, that's it. So for large sample sorry, for large sample cases it remains same, but difference is we have to replace sigma by sample standard deviation S. Okay, standard deviations, there are 2 based on those 2 samples, so replace it. But remember this one, C alpha over 2. Okay, so that you can find the confidence interval for 100 1 minus alpha percent. Okay, check this example, same example we discussed last week. These are sample sizes N and M. Let's say this is N and this one M, yeah, and this one N. These are the sample mean, which mean X bar, this is Y bar. Sample standard deviation S1, S2. Okay, so we need to find the approximate a 99% confidence interval. This means 1 minus alpha or 100% 1 minus alpha. Sorry, 100 1 minus alpha percent. Okay, so which means your alpha is 1%, right? Or you can write it 0.01. Okay, alpha 0.01. Okay. Okay. So simply plug the values to that particular equation. You can find this guy from the C table. That value is 2.575. This one. Okay. So all other values you can find from this table. Plug it, simplify it, then you have your answer. Okay. This is going to be S1 squared. Okay. Okay. Values are correct, I guess. So I think final answer is not there. Just we have to simplify. Okay. Okay. Now, last case, last 2 cases, we either know population is normal distributed, and we know sample standard deviation, population standard deviation, or sample is large enough, so we could approximate to a normal distribution, normal distribution, then deal with the C table and those stuff. But what happens if we don't have enough sample, like less than 40? So at that time, same as the chapter 8 or chapter 7 stuff, we use t-test. Okay, so we can use the t confidence. In this case, we have to talk about t test for two sample as well as confidence intervals. Okay, okay, these are the assumptions we made in the first place in this chapter. First sample, it is random samples, so they are independent from each other. Each samples, they have a mean, this mu1, standard deviation sigma 1. And also the second sample, same situation, they are independent from each other, they have a different mean, they have a different standard deviation. Then finally we assume that those two samples are independent. Okay, so what happen if we have a sample like samples n and m, okay, less than 40, oh sorry, the other side, less than 40, okay, which means n and m, m and n mean they are sample sizes. Okay, if they are less than 40, and also at that time we don't know about their variances. Okay, most of the time if we have simple, I mean very small sample, we don't know about the population standard deviation, so that it is unknown standard deviation or variance, you know, the relationship of variance and standard deviation. We don't know about the standard deviation for these small samples. So same thing, but you have to use t approach, which means you have to use t table. That's why your test statistic, it is t here. Okay, same as the mean difference minus population mean difference. Okay, we know that, divide by square root of, here not sigma, it is s, they are sample standard deviations. Okay, so t distribution, you know that for t distribution we need that alpha and what, degree of freedom. Do you remember, we need these two parameters to find particular t value. To do that, to find the degree of freedom, alpha, no problem, we can find it. Okay, we need this guy, right, degree of freedom. Here we denote degree of freedom by simple v. You have to calculate that degree of freedom. Okay, you cannot simply take like, if you remember last time we consider a degree of freedom is n minus 1, the sample size minus 1. But here in this case, for two samples, you cannot simply take the degree of freedom. So you have to deal with this. Okay, there is no easy way to find this. Definitely you have to deal with this. Okay, there is a situation, we will talk about that later. We can simply use the n minus m minus n minus 2, that kind of stuff to find the degree of freedom. But here, to this case specifically, you have to find the degree of freedom using this equation. Okay, don't forget, for this case here numerator, it is like square root of this denominator. Okay, this denominator, see, square root of that denominator. So this kind of relation is there, but you have to familiar with this equation to find the degree of freedom. Okay, in this case, once you find the degree of freedom, that's going to be like a real number, like 2.5, 5.7, something like that. So at that time, round it up. Okay, if it is like, if this value is, let's say, 2.51, so simply assume that this is 3, because we don't have real values. I mean, we have only integers in that table. So try to round it up. If you need to find the p-value as well, you need this one. Okay, because you at that time you have to convert this one to a probability value. Go to the table and find that particular the corresponding probability value. Okay, so at that point as well, you need degree of freedom. Okay, so problem is you have to use this giant equation to find the degree of freedom. So try to familiar with that. It is just plug in values and simplify. You know, every values every parameter S1, S2, Mn, it's given. You know those values. Only thing is you have to plug the values and simplify it a little bit, okay, and round it up. Okay, two sample t-test for testing. Okay, so you know this is the null hypothesis. In general, this is the null hypothesis. Most sometime this delta 0 going to be 0, which means mu1 equals mu2. That happens. But anyway, this is your test statistic, right? This one. So this is your degree of freedom. This is how you need to find the degree of freedom. Okay, this is the degree of freedom. Refer T table. Yeah, get critical value approach or p-value approach with degree of freedom V. Simple V means degree of freedom. Okay, so you need degree of freedom for critical value as well as p-value approach. But I told you I recommend critical value approach because p-value approach sometimes it gets like more complicated. Okay, so it is easy to use critical value approach. Okay, so same as the previous three cases. If you use p-value approach, you can see it's a left tail test. It can be left tail test, right tail test, or two tail test. Okay, if you use p-value, same way, left tail or right tail doesn't matter. You can find the p-value and reject whether by checking p-value and alpha value. Okay, if it is a two tail test, then you have to multiply that table value by 2 and then compare with the alpha. Okay, same, exactly same as what we have done sorry, in chapter 8. Okay, critical value approach is very similar. For the critical value approach, you need to find this one, T alpha. Okay, alpha means this a significant level. So since it is left tail test, that's why we have used negative. So you don't have to worry about that. Just for the left tail test, those values are negative. Okay, most of the time. So you need this degree of freedom. See, so if this value, once you find the critical value, once you find the T alpha value from the table, if that value greater than T, okay, if that value greater than T mean that value is somewhere here, from here to here, so your value is somewhere here, which means your value inside the rejection region, so you have to reject it. Okay, that's the same idea. Okay, same here. If it is a right tail test, same thing happen. If it is a two tail test, same thing happen, but don't forget, sorry, I think I haven't mentioned here, it's going to be T alpha over 2. Okay, okay, it's going to be left hand side. We reject if something, if your T value is somewhere here or somewhere here. Okay, for this calculation, please use alpha over 2 because this is two tail test. Okay, don't forget that it is same throughout this chapter 8 and 9. Okay, okay. In this subsection, you saw that we are dealing with t-test as well as their confidence intervals. Okay, so this is the confidence interval for this. Always consider this guy, these two guys as a just a one term, so that you so that it is easy. Okay, this one, instead to find the confidence interval for these guys, we have what, unbiased estimate of mu1 and mu2. Okay, these are the unbiased estimators. That's why we use this sample mean and sample 1 mean and sample 2 mean. Okay, so same thing for here. I think I showed this, see how we find this confidence interval for C test. Same thing here, T test. Only difference is this guy. Instead of Z, you have to find T. So this guy, how do we find this guy? Using that giant equation. Okay, always alpha over 2. Other things, I think, yeah, they are pretty similar. Okay, so I always try to show you how they are very similar to each other so that you know what is the pattern. Okay, there is no big deal here. If you know what is the, if you really know what is going on with the C test statistic, how we find the confidence interval for C Okay, so it is easy to move from C to T. Okay, only difference is those C and T's. Okay. Okay, just check this example. Yes, I think I have to do this one. Okay, in this example, they have given the significant level, which means alpha. It is given. Okay. Uh, so yeah, what is their claim? Claim is the mean operative time is less with the dynamic system than with the static system. So you have to define two samples right here. I have mentioned. First one is based on dynamic systems. The other one is static systems. Okay. So based on these two, I have mentioned x1 and x2. Okay, all values are here. They have given. This is the part of question. Okay, this everything from top to bottom is the question. Okay, uh, so n1 based on x1. N1 is a sample size given. That sample mean given. That sample standard deviation given. Second sample mean given. Second sample standard deviation given. Second sample size is given. Okay, so you can see N1 and N2, both N1 and N2 are less than 40. Okay, so you cannot use C. You have to use T. Check this one. Assume both the populations are normal distributed. For T case, we assume that, okay, population is normal distributed. Okay, population is normal distributed. That's okay. But we cannot think about C because sample size are small. Okay, so second, what's the first question? Okay, you have to check this, which means what? Your alternative hypothesis is what? What operative time is less with the dynamic time than, which means mu1 less than mu2, right? Let me check. Yeah. Okay. This is the, because see, less operative time is less with the dynamic system than static time. Okay, sorry, static system. So it's going to be this. Then the second part, you need to find the confidence interval for 90%. Okay, so mu1 is the population mean. You have to define this based on your x1 and x2. Okay, so it is better to write. It's a good practice to write what is your mu1 and mu2. So mu1 based on dynamic group, mu2 based on static group. So always it's not here. Don't confuse. As I mentioned, the mean difference is 0. That's why we have this, because if you remember, we normally write it mu1 minus mu2 equal delta naught. Okay, here in here this delta naught is 0. Okay, because we just need to check whether this is less than this one. Clear? So you can simply assume like this. Okay, this guy like 0. Okay, so alpha 0.05. You can find the test t test statistic, or simply test statistic. This is your t cal value. Okay, here minus mu1 minus, sorry, minus mu1 minus mu2, it is 0. That's why it's not there. Okay, so once you simplify this, you can find the t cal value. Next, the problem is to find the degree of freedom, V, or degree of freedom. So again, you have those values, plug the equation to this one, then you get 17.82. So sorry, always you have to round down. Okay, sorry, I'm so sorry that I told you round up. Always try to round down. Okay, round down. Okay, I'm so sorry, I just missed it, because degree of freedom change your value a lot. To avoid those errors between your real value and between the real value and your value, we try to reduce the degree of freedom value. Once you check the C table, you will see that when once degree of freedom is increasing, that value also increasing. Not like C values. Those are like 1, 10, 100, 200, like that. Very big values. So to avoid that, we try to round down. Okay. Please remember that round down. Okay. So 17.82, you had round down 17. Go to the table, find T alpha and degree of freedom, this 17, that value. Once you check that value, you will see that, see, that value is negative 1.74. Then you can find, you can take your decision. This is a left tail test because it is less than. So values are like this. I think that value is negative 0.17. Negative 17 is somewhere here. Sorry, this one negative 17. Yeah, this is your T alpha V value, and this is your T cal. Okay, so T cal value is less than T alpha value. So what? Reject S0. Okay, reject S0. Any questions? Finally, you have to write the claim based on whether you reject or not. Okay. Okay. Second part, I forgot this part. We have to find the confidence interval based on, I mean, confidence interval, 90% confidence interval, which means alpha is 10%, right? 0.1. Alpha is 0.1. Okay. This is what we found, mean time difference. Okay. So simply find the simply plug the values for that confidence interval equation. In that case, please use alpha over 2, okay, which means 0.05. So you know this 0.05, you know this value, and also you know this value. Here, this value they have taken just positive, because here, right here, we deal with negative and positive, so doesn't matter about the sign, just the value. Okay. This is your x bar, this is, sorry, this is your x1 bar, this is your x2 bar, this is this value. Okay, negative, positive, take care this sign here, so you don't have to worry about negative and positive. And this is your s1, n, s2, n2. Okay, that values. Then you can find the corresponding confidence interval. This is your ci, sorry, 90% ci for whatever they have mentioned, that mean difference. Okay,